we're going to look at how to use the bin packing algorithms to arrange a set of items into groups of a certain size. So we're going to arrange these objects here into bins of size 15, and the first bin packing algorithm we're going to look at is the first fit algorithm. This basically means that we're going to look through our items and we're going to place each item into the first possible bin that they can fit into. So if we start off with our first bin, bin 1. Now we can fit up to 15 in this bin. So if we run through our items in order, we can fit A in this bin. We can also fit B, which is of size 6, so we're up to 8 now. Now we can't fit C in there because that would take us up to a total of 16. So we're going to have to start a new bin, and C is going to have to go in that next bin. Now we're on to D. Now D's got size 5. We still have space enough in bin 1, so we'll put D in bin 1. So in bin 1 we're now up to 13. E. We can't fit E into bin 1 because that would take us over 15, but we can fit it into bin 2. So E goes in bin 2. Right, now up to F. Now F being of size 4, there's not enough space in bin 1 or bin 2, so we'll have to start a new bin. And F goes into bin 3. Now G is only of size 1, and if we look back to our first bin, we're currently up to 13, so we can fit G into our first bin. On to H. Can't fit into bin 1, can't fit into bin 2, but it can fit into bin 3. I is size 12, so we're going to have to start a new bin. So I goes into bin 4. J is also size 12, so that's not going to fit into any of the previous bins, so we're going to have to put that into bin 5. Now, K is size 3. We don't have space of 3 left in bin 1, but we can fit it into bin 2. So we fit it in the first possible bin that we can. So K can go in bin 2, and L can't fit in bin 1, can't fit in bin 2, but it can fit in to bin 3 because there's enough space in there. And so we've managed to arrange all our objects using the first fit bin packing algorithm into the 5 bins as shown. Now we're going to look at a slight variation on the bin packing algorithm. So we're going to use what's called the first fit decreasing method. Now we're still going to arrange into bins of size 15, but this time, before we do that, we're going to order our items in decreasing size. So as you can see, I've taken the list and I've rewritten it, starting with the largest items, going down to the smallest items. And now we're going to do the first fit algorithm again, but we're going to do it now we've got our items in decreasing order. So, starting off at bin 1, we're going to put J into there because it's our first item. Now, I can't fit into there, so we'll move down to bin 2. And I goes into bin 2. We're going to have to start a new bin, so bin 3 for C. Okay. Now that we've got down to B, we can fit B into bin 3. There's enough space in there, so B can go in there because that only takes it up to 14. Okay, D is going to have to start a new bin because it can't fit into any of our previous bins. H is also size 5, so it can't fit into any of the previous bins, but it can fit into bin 4 with D. On to our next object, it's size 4, so E can also fit into bin 4. That takes it up to 14. F, size 4, is going to have to start a 5th bin, so F is the first object going into there. K is of size 3. Now K of size 3 can fit into bin 1 because we can take that up to 15 and J is only of size 12. So we put it back into the first possible bin it can fit in. In a similar way, L can now fit in to bin 2 because it takes it up to 15. A is of size 2. Now bin 1 is now full, bin 2 is full, bin 3 is up to 14 and so is bin 4, so we can't fit A into any of those bins. It will have to go in bin 5. G, final smallest object, is of only size 1, so it can now fit into bin 3, as bins 1 and 2 are already full. So G, our final object or item, can fit into bin 3. So there we've used the first fit decreasing algorithm where we put the items in the first possible bin, but we started off with a decreasing list. The final way of using the bin packing algorithm is to use what's called full bin packing. This means that we're going to look at our items, and as we want to fit them into bins of size 15, we're just going to look for different items that we can put together to make a total of 15. So, for example, if we think about bin 1, if we want some items that we can see add up to 15, we might just want to pick J and K because that's 12 and 3. So we know that we've filled up our first bin and it's full up to a size of 15. For our next bin, number 2, we can again look for items which have a total of 15, the size we want. So we may pick I and L because I is 12, L is 3. So we've filled up bin number 2 now. We've got a full 15 in there. Now when we get to our smaller numbers, we might just have to think carefully, pick our numbers carefully. But in bin 3, a possible set of items that we could choose, if we choose D, F, E and A, sorry, that's D, F, E and A, we've got a total there of 15, so that's another bin that's full up. Bin 4, looking at the items we've got left, we could choose to put in bin 4 C, B and G. So C is 8, B is 6, G is 1. That gives us a total of 15. And anything that's left over, or ones that we can't find to add up to the correct amount, we will just have to put in a bin of their own. So here we'll have to put in H because we haven't put that in a bin up to this point. So in full bin packing, we just, by observation, look for items that make up the required amount, okay, or as close to that total as we possibly can. Now, one thing that you might be asked about any of the bin packing algorithms is whether you've achieved an optimal solution. Now, the way to check this is simply to add up all the items. Now, if you go back and look at all the items in our list, they added up to 65. We were arranging them into bins of 15. So if we think about our items adding up to 65, dividing them into bins of 15, we get an answer of approximately 4.3. And that tells us that the lower bound is 5 bins, because we couldn't get it into 4 bins, so we would need a lower bound of 5 bins. So in all 3 of our bin packing solutions, we did find actually an optimal solution, but that won't always be the case.